Good morning, students. In this video we'll see projection of points. So there are four different projection of points. So by placing the points in four different quadrants, we will get four different types of projections. So first we will take this first angle, means first quadrant. So if a point lies in this first quadrant, we will define this point by two things. One is in front of VP and above HP. So for like this, we will define the points in each quadrant in such a manner. So first we will take this first quadrant. If the point is in first quadrant, we will define it by saying it is in front of VP and above HP. So take that the observer is going to come here. So I will mark the observer. So here our observer is going to come here. So there is no change in the position of the observer. The position of the point may change. Maybe it may be shift to second or third or fourth quadrant, whereas the position of the observer is going to be remain the same irrespective of the position of the point or the object. Okay. So if the point is in first quadrant, this point will be defined as in front of VP and above HP with respect to the observer. Okay. So similarly, if the point is in the second quadrant, it will be defined as behind VP and above HP. Here also there is no change in the observer position. So observer is going to be here only. There is no change in the observer position. The point is in the second quadrant, we will define as behind VP, above HP. Similarly, if the point is in the third quadrant, so we will say behind VP and below HP. So the observer is going to come here. Now if you move the point to the fourth quadrant, we will say in front of VP and below HP. So these are the four different ways we will define a point when it is in four different quadrants. Now we will see how to draw the projection if the point is placed in each quadrants. So first we will take the first quadrant. So now the point is here. So this P is the point. So in the question what they have defined that this point P is some 20 or 25 mm, some distance from this above HP, and this distance, this above HP distance, you can able to realize when you see from the front. So you have to mark this distance, that is the distance of the point from the HP on the VP. That means that is your front view. Whereas the distance of the point from the vertical plane, that means it in the question they have given like 20 or 25 mm in front of VP. This distance P dash to P, this distance you can able to see when you see from the top. Okay, this distance is going to be projected on the horizontal plane. Okay, remember one thing, front view will always be projected on the vertical plane. So this plane is vertical plane. Okay. This plane is horizontal plane. Front view is always going to be projected on the vertical plane, whereas top view will be projected onto the horizontal plane. So this the distance that is above horizontal plane, the position of the point that is from this horizontal plane will be projected on the vertical plane. That means front view. Whereas the position of the point from the vertical plane, which is always going to be realized when you see from the top. So this distance P to P dash you have to project onto the horizontal plane. That means top view. So you can't able to see the top view. Okay, when the observer is here, he can able to only see the front view. In order to see the top view, what we have to do, we have to rotate this horizontal plane clockwise. So the symbol is given here. If you rotate this plane clockwise, what will happen? The horizontal plane will come at the bottom, whereas vertical plane will come at the top. Okay, so it will be like this. Here you see this this xy reference is given. This xy is the reference line, that is the intersection of a vertical and a horizontal plane. Mark this xy. Above the line you have to mark VP. Below this red line you have to mark HP. Okay, so in order to see the top view, what we have to do, we are rotating this horizontal plane clockwise. If you rotate this horizontal plane clockwise, what will happen? Horizontal plane will come below the vertical plane. So this is above the line you have to mark VP, and below the line you have to mark HP in the case when the point is in the first quadrant. Okay, so this distance, the distance of the point from the HP, you have to mark it on the front view, whereas the distance of the point from with respect to VP, you have to mark it on the top view. Okay, front view you have to mark it on VP, top view you have to mark it on HP. So this is the projection when the point is in the first quadrant. Okay, now we will move to the second quadrant. So if the point is in the second quadrant, so again the same, the distance of the point from the horizontal plane, this distance is going to be, you can able to see this distance, that means small b to capital B, you can able to see when you see from the front. Okay, so this above distance, this above the distance of the point B, capital B, from the horizontal plane is always going to be projected on the vertical plane, this vertical plane, whereas the position of the capital point B from vertical plane, means that B dash from vertical plane, is always going to be projected on the horizontal plane, that means top view. Okay, so you now the observer can't be able to see the top view because it is in the horizontal plane. So in order to see the top view, what we have to do, we have to rotate this horizontal plane clockwise. So that is the standard rule. So in order to view the top view, in order to see the top view, you have to rotate this horizontal plane clockwise. If I rotate this horizontal plane clockwise, what will happen? This horizontal plane will overlap with the vertical plane. So while drawing the projection, you have to mark both HP and VP above this XY line. Both HP and VP will come above this reference line. Okay, since we are rotating this horizontal plane clockwise, what will happen? Once you rotate it, both vertical plane and horizontal plane will overlap each other. So the projection of the front view as well as the top view projection will also get overlap on each other. So you have to mark both HP and VP above the reference line. Now we will move to the third angle of projection. When the point is in the third quadrant, so you are going to get the front view on this vertical plane, whereas top view you are going to get on this horizontal plane. So in order to see the top view, what we have to do, we have to rotate this horizontal plane clockwise. If you rotate this horizontal plane clockwise, what will happen? The HP will come above this line, whereas VP will come below this line. So you have to mark the vertical plane below this XY line, whereas the horizontal plane above this XY line. So while projecting the front view, you have to project at the bottom of the line, whereas the top view you have to project above the reference line. Now we will move to the fourth quadrant. When the point is in the fourth quadrant, so after here in this vertical plane, you are going to get the front view. The top view you are going to get on this horizontal plane. In order to see the top view, what we have to do, we have to rotate this horizontal plane clockwise. If you rotate this horizontal plane clockwise, what happens? Both vertical plane and horizontal plane will overlap on each other, but this time both HP and VP will come below this line. In case of second quadrant, both HP and VP will come above the line, whereas in case of fourth quadrant, both HP and VP will come below the reference line. So you have to mark both the front and top view below the reference line. So we will summarize this thing. When the point is in the first quadrant, it will define like in front of VP and above HP. Whereas if it is in the second quadrant, it will be defined like behind VP and above HP. In third quadrant, behind VP, below HP. If it is in the fourth quadrant, in front of VP and below HP. So if the point is in first quadrant, so you have to mark the front view on the HP. That means in the question they have given 30 mm above HP. That 30 mm you have to mark it on the VP because that is our front view. Then another part of the question will be 35 mm. The same point is 35 mm in front of VP. This in front of VP you can able to see when you see from the top. Okay, top view you always mark it on the HP. So you have to mark this 35 mm below the line. If you take the point is in the second quadrant, so you have to mark both VP and HP above the line, and both the front view and top view will come above the line, above the reference line. Now we will move on to the third quadrant. Now you have to shift the position of the planes. Horizontal plane will come above the reference line, whereas vertical plane will come below the reference line. So if it is given below HP, that you have to mark it on VP. That is our front view. Okay, below HP. If it is given behind VP, that distance you have to mark it on HP. That is your top view. Top view will always mark on HP. Okay, the final one is the fourth quadrant. When the point lies on the fourth quadrant, so once we rotate the plane, horizontal plane, what will happen? Both that HP and VP will overlap. But in this case, what will happen? Both HP and VP will come below the line. Whereas in the case of second quadrants, it comes above the line. Whereas in case of fourth quadrant, it comes below the line. So you have to mark both front and top view below the line. Okay, below HP, some distance below HP. That distance you have to mark it as a front view. In front of VP, that distance you have to mark it as a top view. So here D is the top front view, D dash is the top. So now we will see some examples. And so take the first question, point A, 25 mm above HP and 20 mm in front of VP. So if it is above HP and in front of VP, then the point is located on the first quadrant. So we will draw the projection in the AutoCAD software. So once you enter into the software, first set the units in millimeters, then set the limits 0, 0. So I am taking the size of the A3 sheet, so 420, 297, and then zoom all. Okay. So now I am going to put the reference line. So put it for a random length. So I'm going to put it for some 300. Now we will mark VP and HP. Now the point is in the first quadrant. So we have to mark VP above the line, HP below the line. So go to text, TXT text, space. It will ask you to specify the start point of the text. So I'm going to click here. Now it asks you to specify the height. So I'm going to specify the height as 3 mm. Now it will ask you to mention the angle of rotation. Make ensure that it should be 0. If you give some other angle, what will happen? Once you completed the text, it will get rotated according to the angle of rotation you have given. So always ensure that it should be 0. 0 and again space. Now this cursor will blink here. Now we can start typing. Okay, I am going to mark VP. At the bottom I am going to HP. So this reference line I mark as X and Y. Next click outside and then press escape. So I am going to move this closer to this line. Now the question what they have given, 25 mm above HP. This above HP can able to see when you see from the front. So if it is a front view, you have to mark it on vertical plane. So take a line, start from here, from this reference line. What is the question? 25 mm above HP. So switch on the ortho mode and give 25 mm. So at the end of this line, put a point. For point, type PO space and click here. Actually a point is formed there, but it is not visible. Okay, we have to change the style of the point. So for that, in the command box you type DDP type, enter. So here you will have different types of point style. You select any one. So I'm going to select this one, and once you select the point style, next thing you have to do is set size in absolute unit. Okay, you have to select this one, set size in absolute unit. If you give set size relative to screen, what will happen when you zoom in or zoom out, the size of the points will change. Okay, to avoid that thing, what you have to do, set size in absolute units and change to 4. So now you see the style of the point is changed. Okay, this is my front view. Okay, now I'm going to mark the top view, which is 20 mm in front of VP. This in front of VP distance you can able to see when you see from the top. Okay, if it is a top view, you have to mark it on HP. So 25 mm. Sorry, 25 or 20? 20 mm. Okay. Now again put a point. Now we have to name this projection. So click this one, click this X, click this Control C, Control V, place it here. Again Control V, place it here. And now change the point. There in the question, there again point A. So front view, you just put A. If it is a top view, you put A dash. And also in the bracket you mention, put a bracket and mention front view. Copy this one, put it. Specify top view. So this is the answer for the question 1. Now we'll see the question 2. Question 2, point B on VP and 30 mm above HP. If it is given in the question that if the point is on the plane, maybe the plane may be a vertical plane or horizontal plane. If the point is on the plane, then you have to mark the projection of the point on this reference line. Okay, on the reference line. So I will mark it. What they have given, point B on VP and 30 mm above HP. This 30 mm above HP is the front view. So first we will mark that front view, 30 mm. So put a point. Okay, this we got our front view. Next, second thing what they again, the point is B is on VP. So on VP, put a point on the reference line. So this is my front view. So give B. Double click and change the wordings. Control C, Control V. This is my top view B dash. Okay, now we'll move on to the third question. Point C, 30 mm behind VP and 25 mm above HP. So if it is behind VP and above HP, now the point is in the second quadrant. If it is in the second quadrant, what we have to do? We will once we rotate the horizontal plane clockwise, what will happen? Both vertical plane and horizontal plane will overlap on each other. That will come above the reference line. So I am going to place both HP and VP above the line. Now I will get the front view first. Front view is, if it is they have given 25 mm above HP. This 25 mm above HP is our front view. So I'm marking 25 mm. Put a point. Next, what they are given, 30 mm behind VP. 30 mm behind VP is the top view. So when the point is in the second quadrant, you have to mark both the points above the line. Okay, above the line. So 30 mm. Again put a point. So this is the front view. C. This is the top view. C dash. So once you got the projection, next what you have to do, we have to give the dimension. So here you go in the annotation box, you can able to see dimension option. So here we will have different types of dimensioning. So you select the linear one, click on this point, and click another point on the reference line at the end of this line, and then move to the left. Okay, and then place the dimension. Similarly, the bottom also. Again select the linear dimensioning. And place the dimension. If it is interfering with the letter, what you do? Click the letter and drag and keep it on the other side. Okay, the dimensioning should not interfere with any letters. Similarly, you give dimension for this also. So I'm going to give on this side. So you can give it on any either side, maybe left or right. Okay, it should not interfere with the letters you have given. Okay, letters you have defined. Sometime what will happen, this dimension will be very small. Okay, it is not sometime you have to zoom too much to see this dimensioning. If in that case, what you have to do to increase the size of this dimension, you type D in the command box, press space. So this dimension style manager box will open. Here you go to modify and go to fit. You increase the scale. You increase the scale to 8 or 10. Then after increasing the scale, now for me it is correct. It is okay. So I'm not going to change the scale. In your system, if it is coming very small, what you have to do, instead of 1, you give 8 or 10, between 8 and 10, and then give OK, and then click set current. Okay, and then give close. So automatically the dimension will change. The scale of the dimension will change. So now we will move on to the fourth problem. So now we will see the fourth question. The fourth question is point D on HP and 40 mm in front of VP. That means the point lies between quadrant 1 and 4. Point lies between quadrant 1 and 4. So I'm going to take the point is belongs to quadrant 1. I'm going to draw the projection. What they have given, point D on HP. If it is given on HP, we have to simply put a point on the reference line itself. They are given 40 mm in front of VP. This in front of VP is the top view. So I'm taking this point belongs to quadrant 1. That means the top view, you have to mark it at the bottom. PM. The point. The another point is on the HP, so I'm going to put a point on the reference line. So this is the top view, D dash. This is the front view, B. Now give the dimension. So in this case, VP comes above the line, HP comes for this case. So now the point for in the fourth case, the point lies on the plane, that means between 1 and 2, 1 and 4. So I am taking this point belongs to quadrant 1, so I am drawing the projection. Draw the projection by considering this point is belongs to quadrant 1. So next we will move on to the next question. Fifth question, point E 40 mm below HP and 30 mm behind VP. Now the point lies on the third quadrant. Now the point lies on the third quadrant. If it is below and behind, the point lies on the third quadrant. If it is in the third quadrant, what you have to do? We have to mark VP below the line and HP above the line. Right? Because if you rotate the horizontal plane, what will happen when the point is in the third quadrant? To see the top view, if you rotate the horizontal plane clockwise, the horizontal plane will go above, whereas the vertical plane will come below. Okay. So now point E 40 mm below HP. This below HP is the front view. Front view, we have to mark it on VP. 40 mm below HP. Next they are given 30 mm behind VP. This behind VP is the top view. So you have to mark it on HP. Now give the dimension. This is the front view. So they defined as point E. So E, this is the top view. E dash. Now next, point F on VP and 20 mm below HP. The point F is on the vertical plane and 20 mm below HP. Now the point is between quadrant 3 and quadrant 4. Now the point is between quadrant 3 and quadrant 4. I am taking this point, I am assuming this point belongs to quadrant 3. So there is no change in the horizontal and vertical plane position. Take a line. So what they are given, 20 mm below HP. This 20 mm below HP, we have to mark it on VP. The point, and it is, and they are given it is on VP. So on VP means simply put a point on the reference line. So now give the naming. So this is the front view. So F, the top view. F dash. Give the dimension. Next question. Now the point G 25 mm below HP and 30 mm in front of VP. Question number 7. Point G 25 mm below HP and 30 mm in front of VP. Now the point lies on the fourth quadrant. If it is a fourth quadrant, when you rotate the horizontal plane clockwise, what will happen? It will overlap with the vertical plane. So both planes will come below the reference line. Now they are given 30 mm in front of VP. So both term front and top view we have to mark it below the line. So 30 mm in front of VP. This in front of VP means that is the top view. 30 mm. Next what they are given 25 mm below HP. This is the front view. Again front view are mark it below the line on the same line of projection. Okay, that is 25 mm. 25. Now give the dimension. This is front view, point G. This is G dash. This is the top view. G dash the top view and G is the front view. So now final question. Point H at the intersection of VP and HP. That means the point both the front and top view lies on the reference line itself. So take a point, put a point here, put a point on this line and mark both the top view and front view on the same point itself. Control C, H. Click H dash, right, type H dash. So this is the projection of points. So we have seen all 8 different cases. Thank you.